Okay, so now we're going to go ahead and create our training and our validation data. And if we go back to the TensorFlow website here, it kind of explains it, but what's really nice is Keras has a nice utility that's used for taking the data just like ours is in a directory and creating the two sets. So we're going to just define a couple of variables, and let's follow their tutorial just so that we can kind of stay on track. And we'll hard code that, some of those variables in. So they have a batch size equals 32, image height equals what they use 180, and image width equals 180. So that's going to be in pixels, and essentially we're going to resize our images to these square sizes. So that all of our images, when they go into the model, are of the same dimension, and I'll explain that in a moment when we get to the layers of the model. So to create the data set, it's actually quite simple. We're going to import Keras utils image data set from directory. We want to import that. So let's go ahead and go back to our imports, and let's do let's do from keras.utils import image data set from directory. Then we can use that. And let's create another function here. And I'm going to call this function gen training set. And we're going to pass in our directory. That's our data directory. And we're gonna kind of do what they're doing here, but I've just encapsulated it in a function. So so we're gonna call the function. So we're gonna create our train data. So our train data set, train underscore ds, is going to equal to image data set from directory. So we're going to call this function, and we have to pass in some information. So first we got to pass in our directory. So that's going to be that data dir, and that's going to be the same directory that we've generated from this load images. So that's quite easy. Next we want to tell it how much we want to split these up. So a good rule of thumb is you want 70 to 80% of your images for training, and about 20 to 30% used for validation. So they're using 80-20 split. So we're going to follow that same. So we'll say that the validation split is equal to 0.2, which means that 20% of the images is going to be used for validation, and 80% will be used for testing. For training. So next we'll say subset. So what is this subset? This is going to be our training subset. That's our training subset. So we're going to save that into train ds. Next we're going to define a seed. And the seed is used for the RNG, the random number generator. This can be basically any number you want. So I'll just set it to 123. And then here's where we want to set our image size. We'll say image size equals, and we'll pass in a tuple here of height and width. So it's 256 by default. So we will pass in, so we actually need to pass in these parameters. So we'll say image height, image width. We'll pass those in. So image height, image width. Okay, and then finally we need to give the batch size. So we'll say our batch size is equal to batch size. And we need to define that as well in this function, so we'll pass that in. Okay. So that's our training data, and what we can actually do is we can copy this and we can paste this, and we're going to create our validation data. It's from virtually the same function. So we'll call this val.ds, val data set, same directory, same split, but we're going to rename subset. Instead of training, we're going to call this validation. And then everything else here is going to be the same. And then finally, we want to create one more variable. We'll call this class names. And the class names are basically the the classifications. So one is Rose, one's going to be Daisy. So these are all the classifications that are found, and it can infer that from the way that the file, the directory structure is. We have Daisy, Dandelion, Roses, Sunflowers, and Tulips. So those will become our classification, our class names. So we're going to call class names equals train ds dot class names. And then finally we will, we can print that to the console just to make sure that that looks good. So we'll print a formatted string. We'll just say that class names found in directory, and we can put in our class names. That way we can check that it looks like it got them all. And then finally we want to return from this function, let's return our training data set, our validation data set, and let's return the class names because we can use that again later. Okay, so this simple function here is going to take our directory, it's going to extract a training data set, a validation data set, and it's going to infer our class name. So let's go back down to our main function here. We've got these parameters which can be changed. Oops. And let's create train ds class val ds class names is going to be equal to, now we're going to call this function that we create up here gen training set. So gen training set, and we need to pass in our data dir. So we're going to pass in our directory, pass in our image height, pass in our image width, and finally we'll pass in our batch size. All right. And let's go ahead and run this. So if we run this now, we're obviously not going to look at these training data sets yet, but we should be able to see if it's properly extracting the classes, these classifications. So let's run it and see. And just ignore all that stuff. And there you go. So it found the classes that we were hoping for. So it took the 3,670 files, and it found them with 5 different classifications: Daisy, Dandelion, Rose, Sunflower, Tulip. So that looks good. And out of the 3,670, it's going to use 80% of them for training, and it's going to use 20% for validation. So it's going to use these 734 out of the 3670 will be used for validation. So it looks like we have a pretty good setup. So that is how you create the training and validation data set. Next, we're going to display some of these images so we can get a look at how they look at before we go into pre-processing and model development.